The Internet Control Message Protocol, or ICMP, is a Layer 3 protocol used for testing connectivity between nodes on our network. While there are several functions as part of this protocol, such as traceroute and path ping, the most common one that we're going to use is the ping command. And this is just an echo. A single packet or a group of packets is sent from one node through the network to a destination node, which then mirrors the packets back to it. If you get a reply from the destination node, you know you have connectivity to that node. Ping is what we use, especially early on in our early labs, to test the viability of our networks, to prove that the protocols that we've set up, the routing protocols, whatever, are functioning properly. How do we ping? In the physical world, you ping from the command line. So on this one Windows machine right here, 10.1.1.101, I'm going to open a command prompt and ping its neighbor on its own subnet, 10.1.1.102. Ping 10.1.1.102. On Windows, pings go out in groups of 4 packets, although with some switches these can be made indefinite. And you can see I have 4 replies from 10.1.102. The packet traveled to this switch, down to this PC, and then the reply came back this way. Packet Tracer offers a shortcut for pings, however. Towards the top, if you look at these envelopes, they are labeled Simple and Complex PDU. PDU stands for Protocol Data Unit, and the Simple Protocol Data Unit is simply a standard ping. To use this, in the lower right-hand side of Packet Tracer, you see this button with an arrow. Well, if you click on this little window opens up right here. And this window will record your pings. Click on the closed envelope, Simple PDU, and then click on the source node. Now notice my cursor. I now have a little envelope, and I'm going to click on the destination. And right here, we see that that ping was successful, giving us the source, the destination, and other information about it. And this can be used anywhere on my network. I can ping from this PC to this router. I see I'm successful. I can ping from this PC to the PC on the other side, and I am successful. So what this just proves is that routing is taking place. That router forwarded that ICMP packet from my first network to the destination node on my second network, and then routed the reply back to the original source. There are some cases, however, when it might be easier for us to use the command line. For instance, what if I want to ping a specific interface on my router? From this PC, I want to ping the default gateway on the 10.1.1.0 network. And this is why documentation is so important. I can see right here that that address is 10.1.1.1/24. So I can ping 10.1.1.1. And those are my replies coming in from my router. But what if I want to ping the interface on the other network? Ping 10.1.2.1. I'm getting replies back also. This time, it's coming in off the gigabit 0/1 interface over my second network. So the shortcut with the little Simple PDU envelope is certainly convenient when it comes to troubleshooting and testing connectivity throughout our networks, especially as they get larger. Sometimes, though, we need the granularity of using the CLI. One last point. This is a rule that holds true in all of our labs. Even without any routing protocols set up or any other subjects that we're going to be talking about, all nodes in our networks should be able to ping their directly attached neighbors. By directly attached, I mean sitting on the same subnet. So for instance, this PC right here should be able to ping this PC because they are connected at layer 2 via switch. It's also directly attached through the switch at layer 2 to this router. So it should be able to ping its default gateway. And this holds true for all nodes on our networks. If they cannot ping their directly connected neighbors, there is an underlying issue, and nothing else that we do will work until that gets corrected.